Octave is an environment to do calculations in. And so you can write scripts for that environment, kind of like Python, right? When you have a little Python prompt, kind of like that. So that's an interactive environment, and you can write scripts for that environment. There's also programming language aspects to it, and so functions and things like that. So it's more than just that. And people have used Octave and MATLAB to make really, really vast computer programs, essentially. So it's a very powerful tool, and it's essentially a computer programming language, but we're going to use it kind of as an interactive tool here, mostly in these videos. By interactive, I mean you give it a little math calculation to do, and it'll do it for you. 2 plus 2, enter 2 plus 2, it says ants, the answer, equals 4. And you can see up there on the upper left that all of a sudden now there's a variable list, and so ants is a variable. Ants is the latest answer that you have. If you don't want to put it in ants, if you want to put it into its own variable, you can say x equals 2 plus 2. And lo and behold, now we have ants up there. Ants is going to be 4, and x is going to have a value of 4 also. You don't have to declare variables. You don't have to say what type it is. It knows, and it will be able to do everything that you need to do automatically. And so unlike low-level programming languages like C, stuff like that, you don't have to worry about declaring variables. It knows how to do it. There's also a lot of built-in functions. So the sine, all the trigonometric functions, all zillions and zillions of functions are built into MATLAB and to Octave. And so you can take the sine of pi, and two things to note: sine is built in, and pi is a variable that's automatically declared. It's already 3.14159, blah blah blah, right? It doesn't give you 0. It gives you a very small number, 10 to the minus 16th. That's essentially 0. And that sort of points to what Octave is. Octave is a numerical tool, not a symbolic math tool, because the sign of pi in symbolic math would be 0. Here, because of rounding errors and all that stuff, pi is not pi to 1,000 places, it's just pi to 10 places or something like that. And so there's going to be rounding errors in all of your calculations and stuff. So it's a numerical method, and computational science and computational methodologies count here. They're of importance. Good? Yeah, so that's something to note. Another thing to note is that it's easy to make arrays and vectors and stuff like that. MATLAB, MAT stands for matrix. And so Octave, MATLAB, and Octave are really, really good at matrix manipulation, matrix algebra, linear algebra. It's really, really good for all that kind of stuff. So it's got this built-in tool. I'm going to show you exactly how that works. I'm going to declare a new vector, time. I'm going to come up with a time array. I'm going to start at 0. I'm going to go by pi, divided by pi over 8 or pi over 16, something like that, and then get to 2 pi. So you can change whatever interval you want. So the first number is the starting point. The last number is the ending point, and in between these colons here is the increment. So you can just pick the increment, pick how many points you have. So if it's pi divided by 8, you're going to have 17 numbers, right, from 0 to 2 pi. Good? And it comes up. Now, it comes up horizontally, which I don't like, so I'm going to make it vertical, and so the prime works. So the transpose of a vector, in this case, is prime, or transpose of a matrix 2 is prime. And so t equals t prime, it just makes it vertical. So then now it's a column, and it's just my own preference. I prefer it to look that way. You could make a new variable, y, and y is equal to the sine of t. It's just one line. If you've done low-level programming, like C or Fortran or something like that, you have to do a for loop. You have to loop through. Here, you don't. It knows that y is going to be a vector the size of t, and it's going to fill up all the things. So y0, y1, the first element of y, is going to be equal to the sine of t1, and y2 is going to be equal to the sine of t2, and y17 is going to be equal to the sine of t17, so the 17th element of the t array. You don't need to do a for loop. There are for loops and stuff like that in Octave, but you don't need it. For lots and lots of things. You can do this. This has a special name. It's called vectorized. The code is vectorized, where you don't need to to go through element by element. It already does that for you. This makes MATLAB extremely powerful and useful for all sorts of types of mathematical calculations and stuff. It's really great. One thing it's really good for is plotting, right? Plotting in low-level programming languages is hard. You have to export it, put it in Excel, make a pretty thing. MATLAB has all sorts of plotting built in, really nice. It's a very nice feature. So in order to print out that sine wave, you just say plot t comma y, and it comes up. You don't even need to develop the y variable if you didn't want to. You can just say plot t comma sine t, and it'll come up as well. That's pretty cool. If you want to plot more than just one variable, you can do it one of two ways. You can, I'm going to make a new variable z, and z is going to be, the first column is sine, and the second column is cosine. And so I say sine of t, cosine of t in square brackets. So they're next to each other. That means it's going to just be two columns. That's how you define this two-column matrix here, z. And you can say plot t comma z, and both will come up. You don't have to do that. You can just say plot t comma sine t comma t comma cosine t. So it comes in x, y pairs. X value, y value. And then the x2, then another x value, another y value, as long as each x matches the number of points of each y. So x1 matches the points of y1 and x2 matches the points of y2. Then you can print out any number of lines on a graph. And that's how that works. This is sort of an introduction to show how the usefulness of this interactive environment is. The concepts of vectorization, the concept of variables, all that stuff is included in this first video.